Good morning, all of you. In today's lecture, we will study basic milliammeter. In previous lecture, we have started electrical instrument chapter. In that, we have completed multimeter. What is multimeter? What is the working principle of multimeter? And what purpose we are using the multimeter? And which instrument we are using by multimeter? In next topic, we have completed the ensemble movement. Today we will see basic milliammeter. In our practical, we are using milliammeter for measuring the current. In diagram, we are clear that RM, RSH. RM is nothing but internal resistance and RSH is nothing but a shunt resistance which is parallel, and voltage across them, both of them are equal. IFSD is nothing but a full scale deflection which is a 0.1 milliammeter. Voltage current across this RM is IFSD is equal to 0.1 and shunt resistance is nothing but a 1 milliammeter. As the same movement as like PMC for measuring current, which we have taken IFSD is equal to 0.1 milliammeter and shunt resistance is equal to 1 milliammeter. We will convert this movement into milliammeter to across the movement is 0.1 millimeter full scale deflection. For measuring the higher amount of current, we should provide another part for excess current. Suppose this 1 millimeter is converted and the internal resistance can be passed 1 millimeter to 0.1 current. The value of the shunt resistance can be determined. As from the diagram, we will derive the equation. As across the resistance RM, the voltage across them is V movement, and across the resistance RSH, voltage is V shunt. Current across the RSH RM is IFSD is nothing but a full scale deflection into RM. RM is nothing but a internal resistance. Current across the RSH is ISH is current across the shunt resistor into RSH, which is shunt resistance. We will calculate the RSH is equal to IFSD into RM upon ISH. ISH is nothing but a I range minus IFSD. We can call IFSD, IM is nothing but a current internal resistance. RSH is equal to IFSD into RM upon I range minus IFSD. The formula for shunt resistance we have proved. In this equation, if we want any required current, that time we should substitute the I range and calculate the RSH value by selecting a different shunt resistance or different shunt value. By selecting different shunt value, we can see a multi-range milliammeter facility. We should see the multi-range milliammeter facility can be produced. Okay. The only basic thing is milliammeter is nothing but we should check the current across the milliammeter. Second, we will see multi-range milliammeter. Multi-range milliammeter. Multi-range milliammeter is nothing but it consists of a PMMC movement. The movement. The diagram for that we will see. There are three resistors R1, R2, R3. Current across the R1 is 1 milliammeter. Current across the R2 is 10 milliammeter. Current across the R3 is 10 milliammeter. The arrow which is shown in the figure to resistance is nothing but a switch for selecting the different range. It is nothing but a IFSD and RM, full scale deflection and internal resistance. From the diagram we are clear that R1, R2, R3, it is nothing but are necessary as a shunt resistance, and S is the switch function for selecting the range. The main drawback from this diagram we will clear that the switch is changing their position from one range to another range, but that time it intermediate that the shunt resistance in the circuit will not present because the current across the resistor is more amount to the meter, and that time the meter get damaged. That's why the switch should select the at a particular resistor, it should select the current, and across that it will go to meter, and we should check the current across each resistor. Suddenly from at a time the switch will change their range, and by selecting three range at a time, the current across the resistor to meter, it will go the more amount of current to the meter. That time the meter will get damaged. This is the multi-range milliammeter. In that also we have used permanent magnet moving coil. The switch is automatically get changes by in one direction to another direction. It check the first range, then it check to second register, but at a first register it should check the current to meter, and we should note down the current. At a particular register we should check the current. Today we have completed two topics: what is basic milliammeter and what is multi-range milliammeter. In the practical we will check the milliammeter and multi-range milliammeter. In practical we are doing practical by using milliammeter, multimeter. Okay, in practical we are also doing connection by different direction to resistance to capacitor, but we are checking by connecting, shorting the resistor, or checking separate connection to do by doing across the resistor Through multimeter we are checking the current. Same we should understand the theoretically what is milliammeter and what is basic milliammeter. Thank you. In today's lecture we have completed two topics, basic milliammeter and multi-range milliammeter. In next topic we will see earthen shunt method, derivation and basic DC voltmeter. Thank you.